1957, Dearborn, Michigan. Ford bolts a new 4-barrel carburetor onto its Thunderbird and ships it to dealers. Holley engineers thought they were building a production part. They were actually building the benchmark every racing car would be judged against for the next 60 years. That carburetor was the Holley Model 4150, and everything that followed in American racing ran through the bolt pattern of that carb. The Z28 Camaro, the Boss Mustang, the Shelby Cobra, NHRA Pro Stock, 60 years of NASCAR, all of it. This is the double pumper. And the reason it still matters comes down to a single engineering decision that everybody else got wrong. Here is what the 4150 actually is. It is a square-bore 4-barrel carburetor. Square bore means the primary and secondary throttle bores are the same diameter. When the throttle opens, air moves through venturis, narrowed passages, and that drop in pressure pulls fuel up from the float bowls through the main jets. 2 float bowls, one in front, one in back. 2 full metering blocks, one per bowl, with replaceable main jets on both sides. That last part matters more than anything. Before Holley built the 4150, most 4-barrel carburetors had one full metering block at the primary and a fixed metering plate at the secondary. You could change primary jets. The secondary was whatever the manufacturer decided, and you lived with it. The 4150 gave you jets in both bowls. Pull the secondary metering block, swap the jets. You could tune the entire fuel curve without sending the car back to a machine shop. That is what Holley meant by modular. For the first time, racers could tune a carburetor the way they tuned an engine, on the car, on the clock, between rounds. But the modular design was only half of it. The other half was the pump. Every carburetor has what is called an accelerator pump. When you move the throttle quickly, the main jets cannot respond instantly. There's a brief moment where the engine is demanding more air than fuel is arriving, a lean condition. Left unaddressed, the engine stumbles, bogs, or backfires. The accelerator pump is the fix. When the throttle opens, a small diaphragm is mechanically depressed and a calibrated nozzle, called a squirter, sprays a shot of raw fuel directly into the venturi throat. That shot bridges the gap until the main circuit catches up. Every Holley 4150 has an accelerator pump on the primary side. That much is standard. Here is where the double pumper is different. On a standard 4150 with vacuum-operated secondaries, the rear barrels open based on engine vacuum. A diaphragm senses the signal from the primary venturis, and when velocity is high enough, it opens the secondaries. Because the secondaries only open when the engine is already pulling hard, there's enough airspeed through the secondary bores to immediately atomize fuel from the secondary jets. No pump shot needed. The double pumper does not use a vacuum diaphragm. It uses mechanical linkage tied directly to the throttle pedal. You move your foot, the secondaries open immediately, regardless of engine speed, regardless of vacuum. And here is the problem that creates. When a mechanical secondary carburetor slams open both rear barrels at partial throttle, the engine is not necessarily pulling enough air to atomize the secondary jets immediately. The fuel arrives without enough velocity behind it. The engine stumbles. The fix is the second accelerator pump. Mounted at the secondary metering block, it fires a calibrated shot of fuel directly into the secondary bores the instant they open. That pump shot covers the lean condition until airspeed builds and the secondary main circuit takes over. 2 pumps, 1 per bowl, hence the name. For a road car, a well-tuned vacuum secondary carb is usually the right answer. The secondaries open at the right moment, fuel economy stays acceptable, and the transitions are smooth. But for a race car is a different problem entirely. A race engine with a radical camshaft chops up the intake vacuum signal. Aggressive overlap on the cam lets exhaust pressure interfere with intake flow at idle and low speeds. Manifold vacuum drops to almost nothing. A vacuum-operated secondary carburetor on a race engine cannot find the signal it needs to open the rear barrels at the right time. The system is chasing a vacuum signal that the engine will not produce. Mechanical secondaries do not care about vacuum. You move the throttle and they open. On a full race cam, full race intake, high compression engine, the double pumper is the only carb that works consistently. 1965, Chevrolet drops the 4150, list number 3310, onto the 375 horsepower 396 cubic inch Z16 Chevelle. Holley rates the carb at 780 cubic feet per minute. It lasts exactly 1 year as a production carburetor. Not because it failed, because racers wanted every one of them and Holley could not build them fast enough. By 1966, the 3310 was available in the aftermarket. It has been in continuous production for 60 years since. Holley estimates more than 2.5 million units sold. Every significant muscle car of the era ran a Holley. Z28 Camaros, Boss Mustangs, Shelby Cobras, big block Chevelles. The Detroit manufacturers did not go to Holley because they had a contract. They went because the carb made more power at wide open throttle than anything else available, and it was simple enough to rebuild in a field. Then came 1969. NASCAR made Holley the only approved carburetor brand in the Grand National division. Not a competitive advantage, a requirement. Every team, every car, every engine. And Holley arrived at Daytona with something new, the Model 4500, the Dominator, a 1,050 cubic foot per minute double pumper so physically large it needed its own intake manifold bolt pattern. Bobby Reitzman of Holley described February 23, 1969 as the biggest day in the 4500's history. Leroy Yarborough ran it in a 1969 Ford Torino Cobra at the Daytona 500. He broke the track record by 7 miles per hour. His speed was 157.95 miles per hour. They called it the mystery carb when it showed up at the track. Some called it the elephant carb. Holley ran a naming contest for it. The winner? Dominator. NASCAR rewrote the rules. The 4500 was too large for what they wanted. The 4150 came back in a mandated size, 830 cubic feet per minute. That part number, the HP Series 830, listed as NASCAR approved, Winston Cup style, became the circle track racing carb for the next 3 decades, 830 CFM. That number did not come from aerodynamics, it came from a rules committee. Meanwhile, General Motors had their own answer. Rochester Products Division introduced the Quadrajet in 1965, the same year the 3310 debuted on the Z16 Chevelle. The Qjet is a spread bore design, primary Venturi bores of 1 3/8 inches, secondary bores of 2 1/4 inches. Tiny primaries, enormous secondaries, vacuum operated. The small primary circuit gave excellent part throttle fuel economy and smooth street manners. The large vacuum-operated secondaries opened under load to provide air volume for high RPM power. On a stock engine for street use, the Qjet is genuinely good. Better fuel economy than a double pumper, better drivability, cleaner part throttle transitions. It stayed in production from 1965 all the way to 1990. More Qjets were installed on GM vehicles than any other single carburetor model in the company's history. But on a race engine, the Qjet has a problem. The vacuum secondaries need a strong vacuum signal to open. A stock engine with a mild camshaft produces 13 to 15 inches of manifold vacuum at idle, plenty of signal. But a race engine with an aggressive camshaft, the kind used in NHRA competition or serious circle track racing, can idle at 4 or 5 inches of vacuum, sometimes less. The Qjet secondary diaphragm is looking for a signal that engine will not give it. Racers found workarounds. Some drilled the vacuum port to make the diaphragm spring lighter. Some forced the secondaries open mechanically by placing screws through the linkage. Every workaround introduced a hesitation because a Qjet modified to open mechanically does not have a secondary accelerator pump. The fuel arrives without a shot to cover the lean condition. Bog. The double pumper does not have this problem. It was designed for exactly the engine that breaks the Qjet. The Qjet stopped being made in 1990. Holley still manufactures the double pumper today in sizes from 600 to 850 cubic feet per minute.
The NASCAR Holley-only mandate ran from 1969 until the Cup Series moved to fuel injection in 2012, 43 years. The double pumper is still the reference carb when someone builds a naturally aspirated performance engine, not because it is exotic, not because it is new, because Holley got it right in 1957, and the problem it solves has not changed. Holley did not set out to build the most dominant racing carburetor in American history. They built the right carburetor. Turns out, that was enough.